Hi everybody, and welcome back. Alright, so I posted this for you guys yesterday, this bubble sort, and hopefully you read the passage. Let's just hop into it today. Alright, and I know some of you must be excited. It's like, oh look, Mr. Sands is on camera again. Huh, I'm so excited, he's so handsome. Yes, that is true. Finally got it to work, and also got a boom mic, so my setup's even better than before. Alright, so let's say we wanted to sort a list of integers, right? We have this list of integers here. And obviously we could do this by hand, but we could have a system in place, right? A program that accepts a bunch of different values from a user that might not necessarily be in order, and we might want to display them in a way that is sorted so that we have the smallest to largest value. All right. That is pretty easy to accomplish by using one of these several established sorting methods. Now, we're going to go through one of the easiest and less efficient ones first, and that is bubble sort. All right, and if you read this, it's broken down into 3 steps. All right, so step 1, compare the first 2 items in the list at index 0 and list at index 1. If the list item at index 0 is greater than the list item at index 1, swap them. All right, and repeat step 1 by increasing the indices checked by 1 until you reach the end of the array. Then you're going to repeat this process n times, starting at the most recent starting index plus 1. All right. And then by the end of this, our sorted list should look like this. So let's write a bubble sort algorithm. We're going to say public static void bubble sort. That is going to accept, in this case, let's just make it an integer list. All right. Now, we can accept just an integer array as a parameter, because when you pass an integer array to a method, what you're really doing is passing a reference to that array in memory. So this method will work on this exact array, not a copy of it or anything like that, and directly edit it. So this will make things a little easier for us. So in this bubble sort, we're going to start off with a for loop. I'm going to say this for loop has int x is equal to list dot length. This is whatever list is given to us. X is greater than 1, x minus. All right, we're just decreasing the value in x every time. I'll explain this all once we get this all written out. Inside that, we'll have an int y is equal to 1. Y is less than x. Y plus plus. And then inside, we'll just have a condition that says if list y minus 1 greater than list y, then we'll create a temporary integer equal to list y minus 1. We'll set list of y minus 1 equal to list y. And we'll set list y equal to that temporary integer. This is just a quick swapping algorithm that'll allow us to put this value into here and this value into there. All right, so what exactly did we do here? All right, let's just run through this real quick. All right, oops. So and I'll zoom it a little bit. we say x is equal to list.length. Well, that's just how many elements are in this array right now. In this array, we have 1, 2, 3, 4, 5, 6, 7, 8 items in that array. So we'll say list.length is equal to 8. So x is equal to 8 at the start. Right? And then we say y is equal to 1. Pretty good. All right. And now in this inner loop, it just says for each value of y, check y minus 1 and y against each other and see if the earlier one is greater than the later one. All right. So I'm just going to actually write this out right here. We have 56, 78, 43. I immediately realize that I'm going to run out of room. So let's try writing this down here. 56, 78, 43. It might still run out of room, but at least I'm trying. 32, 70, 19. Now we're going to be fine. 33 and 99. Right? That's our list. And so we start off at y equals 1. So what we're going to check is y minus 1 and y. Well, y minus 1 is 0. This is the 0th index. So this right here will be y minus 1. And this right here will be y. And we check them and we see, is 56 greater than 78? No. So we skip those numbers. We go back up to the top of the loop. What happens is y increases by 1 because we have this y plus plus. And so then what we're going to check now, that we've done this, that changes to 2. So now y minus 1 will be at index 1, which is right here, and y will be here. And now we check these values, and we see, all right, is my y minus 1, this red one, greater than my y? They are. So I now have this algorithm that says, well, just a quick bit of code that says, all right, let's put a temp, and let's set that equal to the the y minus 1, the lower index value. So we'll set that equal to 78. Then what we're doing is we're saying, all right, in our list, take y minus 1 and set it equal to y. So then this gets crossed out and it gets replaced with 43. Now this is the reason why we have to have this temporary variable. This will actually leave the scope of memory once we exit this condition, so that'll just not waste any space afterwards. But you see here in our list we have 43 twice. The 78's gone. Our computer would have no idea what that value was if we didn't store it somewhere else. All right, and then this last line says, all right, put list y, set that equal to that temporary value. So now that becomes 78. All right, and we've done our first swap, and you see we're closer now to having an ordered list. All right, and we're just going to keep on repeating this process until essentially all of the large values get shifted over to the right, which in turn will leave the smaller values all on the left in order. All right, I'm just going to very quickly just run through the next few steps of this. All right. So then y increases, we see 78 and 32. Is this one larger? Yes. So then this one becomes 32, and this one becomes 78. Then we check these two. All right, 78's larger, so then this one becomes 70. This one becomes 78. All right, we check these two. This one's larger, this one becomes 19, this one becomes 78. We check these two up. This one's larger. This becomes 33. This becomes 78. And, well, 78's not larger than 99. So, Boom, we stop there. And you'll see by the end of this first run through, we have at least one element in order, right? Because we'll know, hey, this 78 needs to be here. This is the largest value. Sorry, this 99 must be here because it's the largest possible value. No value that we found here has been larger than it because we've always just taken the largest number and moved it along. So we know at least that 99 is in exactly the right place. We also just happen to be humans that know that this 78 is also the largest number here on this list. All right. And then essentially what happens is we run through this whole thing again from the start, except you see list.length decreases, list.length over here decreases by 1 this next time, right? So that x value is going to decrease by 1 this next time through. Because we don't need to check all 8 values. We know that this last value is in exactly the right spot. So now we're just going to check these 7 to see if we can reorder them. Then after we check those, we'll know at least that the last 2 are good. So then we'll check 6. And then we'll check 5, 4, 3, and then those final 2. And then once we're done sorting each of those smaller and smaller bubbles of numbers, we are done. All right, hopefully this makes sense. If it doesn't, pop a note in the Discord for me to check out, and we'll talk about it. But yeah, that's bubble sorting. Yeah. Don't forget to do the attendance, join the Discord if you haven't already, and have a great day. Bye.